Okay, we're still in Module 7. This is Lesson 17, distance on the coordinate plane. So we're going to be looking at the distance between 2 points on the coordinate plane, and we're going to use what we know about the Pythagorean theorem to do that. Okay, so let's get started. So if I have horizontal or vertical lines, it's pretty easy to determine the distance between those 2 points. And there's a couple ways. If they're here, I can just count 1, 2, 3, 4, 5, 6. The distance between point A and point B here is 6 units. Another way I could think about this problem is to say I could look at the difference in the coordinates here. I could say that the distance is 3 minus a negative 3, which I know is 3 plus 3, or 6. So the distance here is 6 units. Okay, and down here, down below, between A and B here, it's a vertical line. I can count spots or I can subtract. And the distance is 2 units, correct? Let's look at another one. All right, so now we have the distance between point A and B here. And this becomes a little bit different problem. I'm going to draw a line between the two of them. We can't just count spaces because this isn't a horizontal or vertical line. It goes at a slant. So I don't know what these lengths are, right? So I need to do something to find this missing length. So we've done problems where we had to find a length like that. So why don't you think about how you would do this problem and come back. So pause, think about it, and then you can come back and listen to the discussion. Okay, so we have been using the Pythagorean theorem to find an unknown length in a right triangle. And so if I told you, if you have not been successful in finding the length of this segment, you might think about it again, knowing that you could use the Pythagorean theorem to help you. So if you need to, pause again with that new information. Okay, I'm going to show you how we can drop some lines. That wasn't exactly vertical. We're going to use the grid lines on this coordinate grid to help us. And I know that that these grid lines meet at a 90-degree angle. So now I have a right triangle. So I've got a leg, and my unknown amount is the hypotenuse. Okay, so we've already seen how it's easy to find the length of legs. The length of vertical and horizontal segments, because we can just count or we can subtract. Like this one is 8 minus 2, so it'd be 6. 1, 2, 3, 4, 5, 6. And this leg up here would be 4 minus 2, which is 2, and I can count 2 units there. Okay, so now this problem of finding the distance between 2 points on a coordinate grid is a Pythagorean theorem problem. So now that I've determined the leg lengths, I can, and let's write it up here, 6 units, and this one is equal to 2 units. Okay, so I've got the Pythagorean theorem here, and we'll let the hypotenuse be C. So C squared is equal to A squared plus B squared. So C squared is 2 squared plus 6 squared. So c squared is equal to 4 plus 36, which is 40. Then I want to take the square root of both sides because I just want to know how long c is. And so the square root of c squared is c, and this becomes a square root of 40. Okay, in this lesson, you're welcome to use your calculator if you're asked to find an answer. This says round your answer to the tenths place. So go ahead and use your calculator on these. And so we could say c is approximately 6.3 units. Okay, let's look at example 2. Again, we have 2 points, A and B, on the coordinate plane, and we're asked to determine the distance between them. This time, first make an estimate and then try to provide a more precise answer and round your answer to the tenths place. So let's go ahead and draw that line segment. And so there's our line segment between, so this is distance AB. We could write it this way, distance AB. And so we want to find that right triangle. And so again, I'm going to just draw vertical segments here. Vertical and horizontal to see these distances. So we can see this is 3 units, and this is also 3 units up here. So we could now make a stab at how big our line is there. We know that it's greater than 3 because the hypotenuse has to be the longest side, so we know it's more than 3. But we can use the Pythagorean theorem here. So let's call our missing length c. So we have c is equal to, no we don't, we have c squared, right? Because a squared plus b squared is c squared. So c is the hypotenuse. C squared is equal to 3 squared plus 3 squared. So c squared is equal to 9 plus 9, or 18. So once again, the square root of c squared is the square root of 18. Square root of c squared is c, is the square root of 18. So 18 is closest to perfect square 16. The closest perfect square to that is 16. So, so the closest whole number would be 4, which makes sense with what we were thinking as far as looking at the legs of the triangle being 3. 3 and 3, we know it has to be more than 3. It doesn't look too terribly much more than 3. So our first guess would be 4. But if we put this in the calculator, C is approximately 4.2. Okay, so length AB is approximately 4.2 units. Okay, now for exercises 1 through 4, you can go ahead and try those independently. Remember, it's okay to use a calculator to get the approximate answer, but also express your answer as an exact answer as well with the square root, with the radical sign. So yeah, go ahead and work on those, pause the video, and come back to see how you did. Okay, so for exercise 1, we're going to draw our right triangle right here, and then our distance will be this distance AB. It's hard to get this right with this fat pen. There we go. That's good. And so we need the lengths of our legs to be able to do this. So remember, there's two ways to do this. You can just count them, or you can subtract the coordinates. So for the vertical distance, I've got 2, I've got 2 minus, and the y coordinates, the difference in the y coordinates here. So I'm looking at 2 minus, it looks like a -4. 2 minus -4. That difference is equal to the same as 2 plus a +4, or 6. So this distance here is 6. And then on the horizontal axis, I've got 4 minus -1. 4 minus a -1, which would be 5. Or, once again, I can count spaces if I have the grid in front of me. All right, so there's our legs. So we can write our Pythagorean relationship here. So we've got 5 squared. Let me use a different color. It's getting busy there. We've got 5 squared plus 6 squared is equal to our hypotenuse. We'll call it C. So this is C squared. So this would be 25 plus 36 is equal to C squared. I'm going to flip it around. So C squared is equal to that sum. So that's 50, 61. 61. So now I can take the square root of both sides. I'll show that in a different color. So the square root of both sides there is going to give me the square root of C squared is C is equal to the square root of 61. Which I can't think of any factors, certainly no square factors, so that is simplified. And then if you, if you can estimate, probably the closest whole number would be 8, because 8 times 8 is 64. 7 times 7 is 49, so it's pretty close to 8. And if you put that into your calculator, you're going to get that approximate to the tenths. That C is 7 8/10 units. All right, this next one, I'll draw my triangle here, and here. There's B, and there's A. And let's get the line going between them. Switching up the colors here. So there's our AB. All right, so we're going to use the vertical distance here is 4. And remember, I can do that by using the coordinate plane or subtracting. This one I don't want to count, so I'm going to do 5 minus -8, which gives me 13. So this is 13. And I got that by doing 5 minus -8. Okay? All right, so we can write our Pythagorean relationship here. I'll do it right down here. 13 squared plus 4 squared is equal to, let's label that C squared. So 13 squared is 169. 4 squared is 16. And that is equal to C squared. So when I add that together, I get 185 is equal to C squared. And then remember, we can take the square root of both sides. It's that property of equality. If those numbers are equal, their square roots will also be equal. So we get here that, and I'm going to continue up here, that C is equal to the square root of 185. Okay, and we just saw that 169 is 13 squared. 13 squared is 169, and 14 squared is, let's see, 196. And so our square root of 185 is somewhere in between there. Looks closer to 14, and if we get this approximate answer to tenths on a calculator, or we could do it by hand too, but this is approximately 13.6 for that distance. Okay? And we knew it had to be more than 13, but probably not too much more because that other leg is pretty short. Okay, next one is number 3. So we can construct our triangle. And the hypotenuse would be the distance. Oops. Oh. Got 5 and 3 on this one. So to write the Pythagorean relationship, let's call this C. So we've got C squared is equal to 5 squared plus 3 squared and we can take the square root of both sides, giving us that C is the square root of 34. We know that's going to be a little less than 6, and for this lesson you've been given the go-ahead to take it to tenths on your calculator, and so you'll get 5.8. These are all pretty much the same. And so, once again, we can count or we can practice subtracting coordinates. For this one, we would have 11 minus 6, which is 5. And for the other one, we would have negative 2 minus negative 6, which is equal to 4. Because I'd have a positive 6 and a negative 2. So my distance here is C. 5 squared plus 4 squared. Let's call it C squared over here. So C squared is equal to 25 plus 16, which is 41. Take the square root of both sides and get that C is the square root of 41. So this time it's going to be a little more than 6, and this one comes out to approximately 6.4 units. Okay, example 3 is, we'll do this one together, a little different. We're asked these 3 points that are labeled A, B, and C, we connect them, would they form a right triangle? Okay, so you might look at that, maybe go ahead and draw the triangle and see how it looks. If one of these is a right angle, it's going to have to be the angle at vertex C right here, right? So this appears to be the longest length. So the difference, what's the difference between doing this problem and the ones we've been doing? Well, a few things, right? I mean, for one, we've been given 3 points to form a triangle. In the other triangles, we were able to subtract coordinates to find 2 of the legs because they were on grid lines. now we've got two sides of this triangle. In fact, the two legs are diagonals, so we're going to have to do something to solve for those. Okay, so think about this problem for a minute, and then we'll continue on. Okay, so we're asked if it's a right triangle. Whoops. We're asked, is this a right triangle? So we should be thinking about the converse of the Pythagorean theorem. So if we can find these three side lengths, which we can, it might take a little doing, but we can. We'll check, let's label this A, B, and C, and we'll be asking ourselves, is A squared plus B squared equal to C squared? We'll ask that question. If it is, then we'll know that this is a right triangle. All right, so what do we need to do in order to find that out? Well, we're going to need to find the length of, we're going to have to find A and B. We know C, or we can easily find C by subtracting 11 minus 1. C is equal to 10. But A and B we don't know. Okay, so let's start with this length A, and whoops, that's not what I meant to do. I'm going to drop this right angle here down to the base of that triangle. So we can see that A squared, which is now our hypotenuse of this little triangle right here, right? So I'm just going to have to find each of these separately. So A squared, the legs here are 1 and 3. So I've got 1 squared plus 3 squared. So A squared is equal to 1 plus 9. So A squared is equal to 10. So A is equal to the square root of 10. Okay, so we've got this side over here. We'll rewrite it's A, which is the square root of 10. Okay, and we've got C equal to 10. So now we just need to solve for B. And we can use exactly what we've drawn here. The legs for B would be 3, and then this distance here, 11 minus 2, or 9. Okay, so B squared is equal to 9 squared plus 3 squared. Or B squared is equal to 81 plus 9. So just continuing up here, B squared is 90. So B is equal to the square root of 90. Okay, so by taking the square root of both sides. So now I know all three sides to that. B is equal to the square root of 90. Now I'm leaving these all as exact answers until I'm all done. Because if I round off, I'm not going to be able to check for the Pythagorean relationship. Okay, but now I can with these. So let's get ourselves some room. All right, so to check for triangle ABC, I want to know if C squared is equal to A squared plus B squared. So C is 10, so on this side of this equation I've got 10 squared. A is the square root of 10. So square root of 10 squared would be A squared, and then the square root of 90 squared is equal to b squared. So I've got c squared, a squared, and b squared. So 10 squared is 100. And again, I'm checking. This is my question. Is that the case? Square root of 10 squared is 10, right? Because square root of 10 is the number that I multiply by itself to get 10. So if I square it, I end up with 10. Square root of 90 squared is 90 for the same reason. So I end up with 100 is equal to 100. And this is a right triangle. Okay, pretty cool. So yes, triangle ABC is a right triangle. Okay, so I know that this is a right angle right there. Okay, so we have looked at finding the distance between 2 points on the coordinate plane. We've drawn right triangles around them so that we can use the Pythagorean theorem. Okay, and we also had practice using the converse of the Pythagorean theorem to verify if a triangle on the coordinate plane has a right angle, and so would be a right triangle. So just kind of simple extension of the Pythagorean theorem. So good luck with that problem set, and we'll see you back here for lesson 18.